So in this activity for a bouncing ball, we're going to look at some still images of someone dropping a tennis ball. So we're going to look at the function with the height being a function of time. So the height h is in feet, t seconds after it's dropped. And what we're going to do is create a table based on these pictures. Now I see here, if I were to make a graph, for our x variable, it would be the time, and our y variable would be the height. So if I see the time is 0 seconds, I'm going to estimate that this kid is about 6 feet tall. So to keep it easy, I'm going to say 6 feet. And at 0.28 seconds, a little about a quarter second, the height seems to be, I'm going to estimate that to be 4 feet. And then at 0.54 seconds, the height seems to be at the ground, so it's at 0. And then at 0.74 seconds, I'm going to estimate that to be about, if he's 6 feet, that looks to be about 2.5 feet. And then at 1.03 seconds, the height seems to be about 3. And then at 1.48, the height seems to be about back at 0. And then 1.88, the height seems to be at 2. And 2.25 seconds, the height seems to be at 0 again. So what we're going to do now is just copy down those numbers on our table. So we have 6, 4, 0, 2.5, 3, 0, 2, and 0. And then we're going to make a graph of this function. Remember, on our x-axis, we put time, so clearly label it. So it's time, and then put our units, which is in seconds. And then on here, on our x-axis, we're going to put height, which again is measured in feet. So we're going to graph this at 0. It starts at 6 feet. 0.28 is going to be about here. We said we're at 4. At 0.54, we're at 0. So I'm going to just put that pretty close to 0.5. At 0.74, we're at about 2.5 feet. At 1.03, we're at 3 feet. So if we're looking at the height, at 1.48, it's at 0. At 1.88, we're at 2. And at 2.25, which would be about right here, we're at 0. So here we have to identify the horizontal and vertical intercepts. So here, I'm going to put that up here. So the horizontal intercepts. And again, that's a fancy word for x-intercepts. So here we have 0.5 for x and 0 for y. So I would put the point 0.5, 0. And then here, this is about 1.25 or 1.48. Sorry, I have that little misgraphed. But here, 1.480. Then we have another one at 2.25 and 0. I estimated from the graph for this to be 0.5. You can put 0.54 if you want to. And then this tells us the tennis ball hits the ground multiple times. So the tennis ball here hits the ground multiple times. So now what we're going to do is look at the vertical intercept. Or that's our y-intercept. And our y-intercept is going to be the point 0 for x, and y started at 6 feet. And that told us the initial height of the ball was 6 feet. Now, our maximum, we have only one maximum value. So the overall maximum is 0 for x and 6 for y. Our minimum values, though, there's 3 that we see in the domain of this graph. So there could be more because that ball is probably going to bounce up and down more. So here we have minimums. And those minimums are 0.54 for x. And the minimum height was 0. Then our other one, 1.48 is 0. And then lastly, 2.250. Again, make sure to list maximums and minimums as points or ordered pairs.